Hey guys, it's Nick. I got another tutorial for you about how to do environmental simulations using a variety of tools in Rhino. What I got for you right now is a simple model, and it'd be pretty familiar to you if you're looking at our like 201 project. So you got our infill buildings, and we've got just kind of a massing model. So it's got thickness in walls and overhangs. Let me go ahead and hide this here. You can kind of see it. It just has some simple openings here, and I don't have any any kind of material for the glass or anything. I've got the staircases modeled as very simple, kind of thick planes. It doesn't have to be that detailed. All we're really looking at here is simulating the effects of the daylight within the space at different times of day. And this is going to use a lot of things that we've already done in like VRay. But this is the kind of quality of model that you need. So you just need make sure you got your overhangs, make sure you got any kind of large openings that are going to be holding glass. Doorways are not really that necessary. You do need interior planes because that's also going to affect the way that light works in the space. All right. And in this case, I did do like an infinite VRay plane, just to make sure that there's a place for light to bounce. But that's about it. So we're going to use VRay, and what we're going to do is we're going to try to simulate the way that light works within our space at various times of the year and various times of day. Should be pretty straightforward. One of the big things though that we have to worry about, and again, if you've already kind of looked at one of the previous videos, we're going to use a VRay sort of like device that's called like a clipping plane, and what that allows us to do is render the light within the space without actually cutting the model. So we're gonna render a section view, but without actually making a physical cut to the model. And what that's going to allow us to do is actually show the effects of having the neighboring infill buildings within the light. So we have this like very narrow space, and it gets very vertical. If we cut the model, then the light would go into it in a way that's not really accurate. So we want to preserve the effect of the infill masses, right? But without actually like removing them. And to do that, we have this clipping plane. You can see this kind of like 3D thing. And the way that you use a clipping plane, and I'll go ahead and like remove it for right now, but is to go into VRay, and you go to VRay Objects, you say Clipper, and that makes your plane. And the plane from default actually, I don't know why they do this, but it sticks straight up. All right, see the arrow is the direction the clipping plane goes, and this is where the plane is clipped. We're going to go ahead and rotate that plane, and I usually just do like a center 0, 0, and I hold Shift, and I'm going to rotate it right this way, and that's where it is. Now, if we want to move it to a different kind of section cut, you can go ahead and pull that any way you want to. I'm going to wireframe here. I'm going to pull it because I want to actually clip my stairs here, because that's a nice section. You could clip it through things like skylights. Anywhere that you get a really spatial section is definitely what you want. And then to get the view in this case, and your mileage may vary, but I'm going to go to right-hand view. I got my clipping plane here. And you could actually clip it. Let me go ahead and get into VRay here, into the asset editor, and I'll do an interactive render. Give you a sense of what that actually looks like here. You can see it. So you can see it actually clips right through it. Right? Looks like a section. Go to my environment here. Make sure I got a sun or a sky. Make sure I've got like the right kind of time of day. I'm going to go ahead and do like 1 o'clock in the summer. You can start to see what that looks like. You got to make sure that even in VRay, you got your... I have it on basic sky settings here. Just make sure that your camera exposure value is set pretty well. I've actually got 15. That's actually pretty good for a wide range of exposures. If you set it to higher, you risk kind of blowing out the image. So just kind of keep that in check. All right, so I got 13 here. That's not too bad. So that's what it looks like. But I kind of want, in this case, you could certainly cut it as a pure section. What I'm interested in, though, is maybe a little bit of perspective so I can see the effect on the inside of the space. So I might go ahead and say, I'm in the right-hand view, pretty straightforward. I'm going to go ahead and go to a perspective view. And you can say, oh man, like, you know, mess that up. I'm going to go ahead and hide the clipping plane. And then zoom all. And now I'm in the space again. Let's go ahead and get back the renderer. And it's still pretty, pretty tight, so I might go ahead and say zoom selected. That's not bad. And it's pretty wide, so you can see there's actually more to it. Once you get a view that you want, right? Remember from the instructions, we're going to be doing a series of renderings from the summer and the winter and the equinoxes. You're going to want to go ahead and save your camera. You can go save view, name views, right? And you can actually save your view. Critical. You want to have the same view all the time, okay? You can also go in, if this is not the view you want, you can go to set view, set camera, and adjust lens length and dolly, and you can make this more or less flat. I would err on the side of somewhere between, like a really deep perspective and a section, just a flat section. I think it needs a little bit of depth. Up to you. But what's nice about this, so we're looking at this, you can see we got our sun options on. You guys know how to do this. I'm looking at 6:21 at 1 o'clock p.m. You can see that I get light, in this case, into my courtyard, the space between the two buildings. I'm getting a little bit of light through my skylight. It's not too bad. So the times, and these are all in the like in the handout. So you might be looking at 1 o'clock, 4 o'clock. Let's get this thing to go here. You can see some pretty diffuse light there. Things like maybe 10 o'clock in the morning. Oops. Of course, yeah. Again, a ton of light in there in that courtyard at 10 o'clock. In the different times of year. So I might go 12 o'clock. Sorry. You might go to like December at 10 o'clock. December at 1 o'clock. Nope, PM. That's around there. There you go. Lots of light in there. So you can see the design's not too bad. It has these big overhangs, which actually prevents a lot of light in the summer, but actually will allow quite a bit of light when the sun is lower in the winter. So, not such a bad design. Of course, this is the interactive renderer. You don't want this for the final render. Go ahead and stop that. When you're making your output, you want to go into the asset editor, turn off interactive, turn off progressive, turn off GPU. Set your quality. I actually rendered it very high. These are not very large renders. You could, remember, you're making a matrix of these, so they don't need to be huge. I set it for high quality. Go ahead and go, and 800 by 450 or 1200, for example. I would make them large. For the site, it is kind of a wide site, so widescreen is not bad for the aspect ratio. Go ahead and render it. I'm going to render it low because I just want to do this quick for the video, but I'm on, again, non-interactive render. I'm in the final renderer. Same exposure value for all my images, right? Same, height and all that. Go ahead and render it, and the renderer will pop up. And again, this should, it'll go ahead and do the geometry. You can see the bucket. Oh, we got a problem here. It's not rendering with the clipping plane. That's not cool. Oh, okay. So just make sure that you turn on your clipping plane. Just make sure that you show it. It needs to be visible. Yeah. Then if you render it, it should be fine. That's my bad. So just make sure that shows up in your viewport. I did two materials, and I know you guys know how to do this. I did the kind of a darker material for the other buildings and for the ground, and I did a lighter material for my actual project. And I just made buildings. And if you look at it, the settings, it's just a darker diffuse. I go to the generic other material and made it more white. That's all I did. Nothing reflective, nothing crazy, but just so that there's some good contrast between the two materials. And this is not final quality. I would render it high or very high and just take a few minutes. You can see how kind of fuzzy it is, but basically you get the idea of it. And then when you're done, you go ahead and save it. I've been saving as a Targa. It's TGA. And the reason I do that is because later on in Photoshop, you have the ability to use the alpha channel to change the background if you need it, so you don't have to have this kind of sky that you've got. So that takes care of most of the information you need to get these renderings of the different kind of daylight conditions. In Section, you're going to do a series, like a matrix of these, 3 times a day for the 3 like important days of the year. Also, renderings for sunrise and sunset, like an hour after each, to make sure that there's no glare in the space. This is very similar to what you guys did in 345, but hopefully it's a little bit more clear as a rendered simulation. For this next part, we're going to look at the solar envelope of our buildings, and we're going to use a program called DIVA. And what this is it's an environmental simulation plugin for Rhino, and there are also components of it that work with Grasshopper. And the way we work it with Grasshopper is interesting because we can really easily change the parameters of our design or change the DIVA parameters in almost real time and like see the results. So that's the mode that we're going to be using. And you look at this model. This is a version of the model I showed you before, but it's just very simple. It's a massing model. I've got my buildings that are next door. I got my infill project just as massing, just as the kind of envelope, and the overhangs that I've got, any kind of roof structure that's going to be like influencing the shadows of my building. And the shadow study is going to be there to show me kind of like where shadows are going to occur across various times of the year, so that I know, where I've got light, where I've got shading, and I know where the neighboring buildings might generate shade on my building. And, this is really not an analysis that has to happen at the end of your project. Like, it's something that has to happen, during, when you're designing it, so that you can kind of see the effects of your design decisions, and then you can design a response to it. It's not something that you do for the final review, just so that you show, like, okay, here are where the shadows are, okay? It's really like a design tool. It's not a presentation tool. And towards that, you really have to be careful to make sure that your building is oriented, north to south, or that you've made sure that those parameters are really clear. In this case, yes, south is the bottom and north is the top, okay? But just really make sure that you understand that, because that'll definitely affect the way that the simulation works. And it's really embarrassing on review, when you don't even have the sun in the right place, right? So here's the project. I actually go ahead in this, and I do try to make sure that I've got, like a camera saved or something like that, so that I always have the same view. Go ahead and run the analysis first, but I just want to make sure that you're, because you're going to be running multiple sun studies and multiple solar radiation studies, that you're at least using a camera. So, but in the meantime, we'll go ahead and start the DIVA study. And if you go to the DIVA component, I gave you guys a file for this. You're going to go ahead and install it. It should work with a demo for at least 30 days, and then you should have your license within the next week or so. But once you install it, you'll have the DIVA components here. You go to the sun, and you're going to use a sun path component. And immediately when you pop the sun component in, you can see that you get a nice little rendering of your building in kind of almost as kind of a cartoon view. And you get this nice kind of solar path. These are all of the kind of like paths of where the sun is going to be for our location over the course of the year. And, it's expecting a north-south orientation. And it's all based on this component right here. We're going to do a few things, though, to get the component kind of working. Right away, we're going to go into like the location component, and we're going to change this. And you can input exactly where you are, but for the meantime, for this class, I'm just going to go ahead and do Chicago. It's pretty much the closest that we've got. It's not that different. There's ways to actually put something directly into the location component via an EPW weather file, and if you need that, if you want that, I'm happy to talk to you about that. But for this, we're not going to worry about that. We're going to go ahead and use just like Chicago. It's close enough to Des Moines that doesn't affect too much. Okay. Then the other things we're going to do is we're looking at the center of the diagram, and in this case, the center is actually going to be. We're going to do that by making a geometry component, which is a container for all the geometries, right? Select everything, and say select multiple geometries. Now we're all in the system. We're going to go to a bounding box, and a bounding box just creates a polygon that represents all of the geometry. We're going to do an area component, which gets the centroid of the bounding box in world coordinate space. All right. And we're going to actually, in order to make this work, I messed this up. We're going to go do a union box. And a union box represents all the geometry. So I right-clicked it and said union. And now we have the centroid. Okay. Otherwise, you're getting the centroid of all of the geometry and their bounding boxes, and we don't want that. Okay. Something else I do is I'm going to go ahead and project that. I get the wrong project here. Pardon me. Yeah, I'm going to project it onto a plane. Centroid, and the plane is going to be XY, which is the default plane, just to make sure. Yeah, it's already on there anyway. And that is what I'm going to plug in for my point. It's not dramatically going to change it, but just make sure that the center is truly the center. And if you go ahead and hide all this, you can see it's now the center of everything. And then for the sun path, I'm going to go ahead and do a radius. So I need a number slider. Make this fairly large because I don't know what I'm going to need yet. And you plug it in, and the radius is the size of the whole shebang here. And I've kind of found that for this model, maybe 125 units seems to be fine. Just big enough. You want to kind of want to get it to the size of the shadow, and take that into like the diameter of it. And also, it's also to create the diagram and make sure you have like this kind of solar angle. Okay, so I got that. No problem. The other thing I'm going to do is I'm going to make a panel component, multi-line data. And actually, I probably don't need that. So this is the month, date, year, or month, date, and hour. Sorry, and I'm going to go ahead and do June. So I'm going to say 6, because June is the 6th month. You can see immediately it's going to change where the sun is. And then the next one is going to be, I copy that, the date, I think the 21st, and then the hour, which in this case is going to be, well, actually take that back. So you've got the month and date, and then because we actually want to see multiple shadows, I'm going to use a series component, because I can make multiple numbers with a series, right? And in terms of the series, I'm going to go ahead and start my series at 9 o'clock in the morning. It's like when I begin to see the sun. So I have the first date, and then I have the step size, and the step is going to be 1 hour. And you can change this if you want, but I think for the parameters of this assignment, it makes sense just to do it for 1 hour. So every hour, and how many hours? Well, I'm going to go ahead and do 8 hours. So it's going to be from about 9 o'clock in the morning to about, 6 o'clock. So I'm going to do 8 hours. So I have 9, 10, 11, 12, 13, 14, 15, 16. So actually, like I guess from 9 to 4 o'clock is about right, and like 8 hours. And I plug that in for the hours, and you see that I have multiple kind of suns here. So I have 9, 10, 11, 12, and then what that gives me is the kind of gradient, like the overlap. Like I have multiple kind of shadows for each one of those times, and then it's going to give me the kind of envelope. And if I change my date, so let's say I change from June to, let's say, the equinox, the 9th, to September, you can see how that angle changes. And now it's really about the kind of shading that occurs on the face of the building, on the face of the other buildings. Courtyard's very dark, right? Once again, if I go into the December, look at how low the sun gets here. A lot more the sun in my clear stories, a little bit more of the courtyard, right? And that's what we're talking about. So those different dates. And so what you really want to do is get a camera set up so that you can study that and get the kind of envelope in. You can go ahead and play with the lens length a little bit, just to get us in the space, and then kind of zoom out. It's up to you, and it's kind of an aesthetic, kind of issue, but I think you want to get the courtyard and kind of try to get underneath those a little bit. Kind of aesthetic issue. Okay, so let's see here. Maybe a little bit flatter. I tend to go a little for depth, but I want to get all that in there. So anyway, you can go ahead and do that. Set your camera. Let's call it shadow study. Very important to have the same camera. And then you got your Grasshopper script. It just makes sure that you get, this has all the dates for winter, and then you go into equinox, right? Going into summer. Just make sure that, you're looking at what you want to study. It's not just about finishing the assignment, but it's about taking the project that you're already doing for 201 and understanding where that light condition is for your side of the street, for your particular project. If you have the other side, you may actually be looking at it from this way, right? So just be sure that you're comparing what you want to compare. And once you've got it in, again, making sure not to change the camera, you can go into, let's see here, I think you want to go to View, Capture, to File, and you can save it as a JPEG or a PNG or a TIFF. And that's how you get those 3 images. Okay? So that's a way to look at the study. And what you're looking for is where your building is casting shadows, where the neighboring buildings are casting shadows. You may be more interested in things like, for example, your courtyard, if you have any, or any kind of interstitial space or transition. But just making sure that you're not getting too much shade or too much glare in that space, and that's the advantage of this light study here. You can totally if you wanted to do a series for the month or for the day, you can absolutely you could actually graph the whole year at the same time if you wanted to. But for this assignment, we're looking at the 8 hours excuse me, from 9 o'clock to about 4 o'clock over the course of the equinoxes and the solstices. But again, it's kind of your call. That's what this component does with DIVA. Makes this really great visualization, and I think it's pretty useful. So for the last part of our analysis, we're going to be using the tools in DIVA to look at solar radiation, and this is the amount of accumulated sunlight and heat that you're going to get over a given period of time. And this could be over the course of the whole year. It's sometimes more productive just to look at the summer months and to look at the winter months, and that's what we're going to be doing for the assignment. So I got back to the basically like massing model, and that's pretty much all you need for this. You don't really need the openings. Like later on, you can put the openings into your analysis drawings to see how they to see how they correspond to where the solar radiation is. But really want to try to keep the geometry as minimal as possible because this is going to be a pretty hefty kind of simulation, as you'll see in a minute. So to do this, go ahead in your DIVA components in Grasshopper, go to Simulation tab, and we're going to drop Radiation Map. And this is pretty similar to what we did with the shadow study, but it's going to visualize things a little bit differently. So first thing we're going to do is add a panel component, and we're going to give the simulation a name, and this allows Grasshopper to store the data that's coming out of DIVA. And so I'm just going to call this my simulation. And it's pretty much a good idea. And for each one that you do that's different. So if I have a different project, I would actually give it a different name. So go ahead and plug that in for name. and then the grid, and this is the analysis grid. So these are the pieces in the analysis that are going to receive the solar radiation grid. So this is what's actually going to be visualized. And then the objects are actually going to be the context. So anything that's not going to be analyzed, but it's going to contribute to the analysis. All right. I'm actually going to go ahead and I think I've got, yeah. So just make sure to unlock everything. Just make sure. Okay. Yeah. So it's just what's being visualized there. I'm going to go ahead and turn the grid off too. So grid, show axes, show rolled axes. There we go. Just to kind of clean things up a little bit and go back to the shaded view. Okay, go in. So I'm going to go into the setup, and we're going to use is a daylighting grid. And the daylighting grid is going to contain geometry. So we put in the geometry container. You're going to select these objects and say set multiple geometries. Plug it in for geometry. You can see that there's a grid already on there. I'm going to go ahead and hide those now that they're in there. And then the spacing for the grid. So the grid spacing is the density of the analysis. So the larger the cell, the lower the resolution, and the faster the simulation is going to take place. But again, it's kind of low resolution, so you're not going to get a lot of fine data. If you make the cell smaller, it's going to take longer, but you're going to get that fine data. So you want to try to strike a balance depending upon the size of the object you have. This is not very large, so I'm going to go ahead and I am going to use a number slider so that I can change this later if I want to. I'm going to make the maximum cell size 10 and the minimum cell size 1. And I'm actually going to go ahead and just use 1 for the grid for this case because I just want to see what that looks like. Actually, for the first analysis, I'm going to go ahead and use a 4. You can see that that's not very high resolution. Okay, then the next piece I'm going to use is going to be a context, or is going to be a scene grid, which is going to be for my context. And this has geometry, but it also has this sort of like material, and we'll talk about that in a second. So we're going to go ahead and make a geometry container. Plug in our context, which is the neighboring masses. Say set geometry. And then I'm going to sneeze. Nope, not going to sneeze. Wait a minute. Not yet. I might later. Okay. So I'm going to hide those. Pardon me. There we go. Okay, so I've got the geometry in for context. And I've got the like the material. I'm going to click this drop down. This is exterior. I might call this like outside facade, like 30%. Just because we're thinking about like what's like next door to it, and I think it's not too bad, just as a rule of thumb. And then here I don't really need. So when you zoom into these kinds of things, you get these little sort of like minuses and pluses. This means you can hide these components if you need to. I don't need the whole rhino scene, so I'm going to go ahead and turn that off. For location, we talked about Chicago for this class. We're going to use that for right now. Of course, later on, you can plug in your own exact location. And then for the scene quality, I'm going to go ahead and use low for like the simulation. Then the last thing I'm going to do is I put in a toggle component, and this is like a little light switch. And when you pop it into the radiation map, when you double click it, it'll start the simulation. And we're going to open up DIVA. DIVA is going to send all these parameters to the command line. It's going to run the simulation, and then it should actually output all that into the scene. Oh, but so we ran the analysis, but we don't have the information in the scene. So then that's my bad. So what we're going to have to do is visualize that with the grid viewer. Yeah, and we plug that in. You're going to get, this is the solar radiant exposure in kilowatt hours per square meter. Actually, well, this looks like it's in meters right now. And you can see, if we look at it, the undersides of this, not getting a lot of exposure, but definitely the front of our building is getting a lot of exposure. And actually, I can probably go ahead and, I can hide, or turn the preview off. Oops, I don't want that back on though. There we go. So there we go. We got this diagram, and you can look at the diagram by going to your front and side views, And if you do a file capture, let's see here, view capture, you can export it. But we're not done yet. So a couple different things. One, that's not very high resolution. So if you go back, change that resolution, and it'll rerun the entire sort of simulation. Now that one didn't take very long, right? This one's going to take slightly longer because, of course, we've increased the density by about 4 times. It's going to take a second to update probably. And this is, kind of like rendering. It's something that's pretty computationally intensive. There you go. So now you can see what's going on in there in our simulation. Still getting quite a bit of light in there. But not on the north side, which is fairly what we'd expect. You can see as you get down into the kind of the courtyard space in here, not as much solar radiation. It's actually quite a bit. Okay, the other thing. Let's see what this is saying here. Oh, yeah, that's fine. As long as it runs, that's an okay bug. So a couple things. I mean, one of the advantages of running a simulation in Grasshopper is that it's very easy to change this kind of these forms or this kind of like Rhino geometry, and then to run the simulation again. And because it's in Grasshopper, you can turn off the simulation, make your change in Grasshopper, and then run the simulation again, and you get immediate feedback. And that's really, really handy when you're trying to design something. Remember, simulation is not just for the final analysis, right? It's actually something you want to be designing with. You want to be running it as you're thinking about the design, like schematically, before you get too far, through the design. That's what makes it really powerful. Okay, but we're not done yet. This actually runs the simulation for the entire year, and what we're going to do is actually we're going to add a start date. Let's see if I can get that to come out, and that's going to be T0. And we're going to add an end date. And see, right now, the start date is 1/1, end date's 12/21. And we could also add like the time of day if we wanted to. That's 24 hours. Okay. So we could only analyze it, for example, during business hours. That would be fine. But let's go ahead for right now and just run the simulation for like the summer. So I'm gonna go ahead and plug a panel in here. And let's see here. Let's call it 621. It might not like that. There we go. Okay, 621. And then we'll copy it. And it might do the same thing. It might kind of hang it up a bit here for a second. To 921. Okay, that didn't hurt. Okay, then we're going to go ahead and toggle true. You can see that it's going to take less time because it's actually not simulating as many days. Okay, yeah, there we go. So for the summer months, actually not too bad. Why? Because we have these big overhangs, right? It's exactly what you want. You want to keep light from getting down in there. So not too bad. You can see how different that is from the other simulation. Okay, let's go ahead and change it. And we'll go ahead and do like a winter simulation. So I'll do what I consider winter, I guess. Might do 921. Well, let's see. Yeah, just for now. So that was about 3 months. I kind of want to do, let's see, maybe 1221. Oops. Uh-oh. We've got the toggle running, so it's gonna automatically. Yeah, okay, I can stop it. Good. Okay. Look in the brief. I'm probably gonna have different parameters for what I consider summer and winter, but I think you can get the general idea of how to run this. Again, you get different data though. If you see it just completely accumulated over the year, I don't think you're getting like the whole story. There we go. Okay. So yeah, I mean, we definitely get some more. We get a lot less light back here, a lot less exposure right on that north side. And then we get this exposure that's running through here. So yeah, this kind of information, which is really nice just to have as sort of like a visualization. And again, it's pretty easy to output these just with the file capture. So you go to view, capture to file. We can save it as a JPEG, save it as a TIFF ping, that sort of thing. Make sure you get the scale in there. You're gonna have to do a little bit of photoshopping in Illustrator to kind of fix it. I like to see like a ground line. You could also, if you wanted to turn off. Yeah. So I think just thinking about this. Yeah. So if you wanted to like turn that off, that might make it a little bit easier. I would still kind of show the envelope of the neighboring buildings. I think that's pretty important. Let's see. Yeah, so we can just look at the various views. Pay attention to what side you're looking at. It's not maybe your front view. This might be the south facade, right? And it's not like the back view. It's going to be the like north facade, right? But you just want to make sure that you get a good sense of what that color gradient is. The other thing you can do too is, we won't get into this too much, but these other values here, so like the solar energy density, this is the density received by the four objects in the scene, and then this is the total solar energy, and you've got all the data values. Like if you actually go into the panel component, you can see these are all the values for every individual object, every individual cell, and there are all kinds of things that we can do in Grasshopper with these numbers. For example, dynamically changing the facade, by making something larger or smaller opening, changing the color of it, changing the material of it. So it's not just a simulation after the fact. It really can be like a design tool that you can use to push information back into the model, and you can use to change the building form. It's something we're not really going to cover like in a lot of, in really any detail here. But just want to let you know, like this is not, just as simple as it seems. Like there's actually a lot of stuff that you can actually get out of it later. You have so these are the point locations, and this is the data that you have with that. And there's different kinds of things that you can do. If you have a lower resolution model, for example, you can actually, and I'll just go ahead and do this. Let's go ahead and make this pretty big, but just because it's going to take a second, so I'll go ahead and do a simulation here. Really quick one. Okay, so there's this model. You can go into preview, and you can bake the data as a series of points, and you can actually visualize it on the object, what that value is, or what that solar radiant exposure value is for that model. And that's kind of an interesting visualization tool as well. And that's actually in Rhino. Like these are point objects. And each mesh that's actually saved to it will actually have the information. It'll actually tell you what that value is, which is actually kind of cool. So anyway, just another way to visualize it for you. But you notice, right? I had to make the spacing pretty large because otherwise you're never going to be able to read it. So lots of different options. I really like working with DIVA. It's great to work with the stuff like in real time, and it's a really good supplement to the work you're doing in like 345 and what you're going to be doing in your later classes. So take a look at it, look at the brief, make sure you follow the directions, and we'll see you guys in class.